Hi, good afternoon, everyone. I hope you are doing well. I hope you are fine. And thanks for joining me for this session, Building Smarter Apps with MLKit for Android. I'm hoping that by the end of the 40-minute session, you'll be able to, you'd have gotten one or two things that would help you to build your smart apps. So, yeah, let's get started. My name is Omolara Adejuwon, and I'm joining from Lagos, Nigeria. I currently lead the Android engineering team at Kudi. At Kudi, we make financial services accessible to Nigerians, focusing on the unbanked and underbanked people. So I currently lead the engineering team, making our applications, and then making them available for Nigerians, basically. And today I'm talking to you about how we've basically used ML kits to solve some of the prominent problems we've had in the past and how successful that has been so far. All right, so ML kits it has lots of vision and natural language APIs that helps to solve everyday problems from face detection to object tracking to lots of other APIs that are available for just everyday real life scenarios. And how, so I'm taking you through almost all of them one by one and how you can implement them in your application and how possible use cases for each of these API. So you might be wondering why you would consider, excuse me, you might be wondering why you would consider ML kits. And for a fact, one of the things that meant so much to us in Kudi was because it's a African it's an African country. Nigeria is an African country, and most in this part of the world, internet access is still a struggle. Memory space is still a struggle. So we wanted a solution that would, be very fast while still being able to provide solutions to these everyday problems we had. And then, so on-device processing was one thing that sold ML kits to us because you want internet access to do some processing. So on-device processing is one of the reasons why ML kits was so much of a choice for us. And also we have the optimized. It's actually very optimized for mobile because it's on device processing and because it works offline. And then the package has been done such that it's strictly for mobile devices. It works on iOS, it works on Android. So it's a no-brainer to have this done for us. And also, like I said, it works offline. So once you've been able to add dependencies to your app, all the processing, every other thing that you need the MLK to do for you is done on the device and it's available offline. And you don't have to worry about internet connection because in Nigeria, yeah, so most of our users are people in remote areas where internet access is such a luxury to them. So we have to, put these users in mind when we're choosing the tool to use. And also, it rests on Google's existing ML models, lots of machine learning models that lots of years of expertise and experience that Google has used to build this. So MLKit is built on these years of experience. So you have lots of models available already for you to use without you having to, rack your brain. And it's quite easy to use also. And then some of the APIs support custom models, not all currently, but some of them support custom models. That means it's customizable depending on your need and use cases. And it's actively being worked on. So for ML Kit, there's an early access program where you can sign up for new features and new releases even before it goes out to alpha. So it's something that is actively being worked on, and it's not an abandoned project basically. So it's very very because of these features and these points, it's very very easy to use. Just add dependencies to your application, and then you are good to go. So MLKit has, like I explained earlier, MLKit has both vision APIs and natural language APIs. So one of the vision APIs is face detection. So vision APIs actually mean that it uses your camera and your images to process whatever you've sent into the ML kit for processing. So Vision API, one of the APIs available under Vision APIs is face detection. Basically, it lets you detect faces, and yeah, basically that's it. It lets you know the faces available in an image, probably a live streaming image or a still image. So because MLKit works offline and it works with multiple faces, you can use it in real time depending on your use case in your application. It works in real time. It works for just a one-time scenario and all that. So you can detect faces in real time. You can scan barcodes, and it works with different types of barcodes: linear, 2D, QR code, and lots of different barcode formats. And also, we have the text recognition. It lets you detect text in a large text. So let's say it scans the text to your screen, and you can do whatever you want to do with that information depending on your excuse me, depending on your use case. And then we have the image labeling. It helps to identify images. In an image, you have different labels. Say, for example, you want to process an image. It lets you know the possible type of object or image this is. And this works well with your custom models. In case, I mean, if there's an existing model already packaged with the ML kit, or for your own scenario, you might want to develop your own custom model or classifier or identifier. You can easily use TensorFlow Lite to, bind your custom model to this ML kit to give you the best experience for your application. And then we have object detection and tracking. So in an image, it detects objects. For example, let's say you want to process an image that a face was wearing glasses. It lets you know that there's a glasses on this image. It lets you know that there's a watch on the table. It lets you know that there's a ring on someone's finger. Like, it detects and tracks images on your behalf. And then there's a new one, post detection. Is recently released. It was in early access program for a while, so it's recently released. And then it lets you determine the positions of human bodies. Like, for example, let's say someone is cutting and all that. So a use case for that will probably be a fitness application where you want to know when a user is currently squatting, and you can count on behalf of the user, or you can detect the angle of the parts of the body. So it lets you know what possible poses, and it gives you a confidence score also. So you can do a lot with post detection. And then the last one under Vision API is we have entity detection. It's still in the early access program. It's not being released to the public, so you would have to sign up for this program to have access to that feature. But basically, what it helps you do is that it helps you identify entities like phone numbers, URLs, addresses, location in a large text. So each of these types of entities it helps to automatically detect that in a large text. So let's say you have a business card, or you have what's it called, or you have a bunch of text with hyperlinks and all that. So it helps to get the entities out of a large bunch. So that's the entity extraction. So like I said, it's still in the early access program, so you would have to sign up for that program to have access to that feature. Then we have the natural language processing. APIs rather. So under that, we have the language identification. This basically allows you to identify the language a text is in. So this scenario works well for a user-based chat application where user provides a text, and then you are probably wondering what language this is in. So it helps to identify languages. And also we have text translation, that this is the Google Translate coming on device. And the beautiful thing is that all these things work on the device. So you won't have to need internet connection and all that stuff to process your texts. And then we have smart replies also. I know at least once in recent times you would have experienced a chat application suggesting replies for you. even your email and all that stuff. So one of the APIs available for under MLKit is Smart Reply. So it suggests what a reply could be, your reply could be based on the conversation you've had with the third party. So I'm going to be talking so much on face. I'm going to be focusing a lot more on face detection. Most of these APIs, they look alike. The dependencies you need to bring into your app, the how you process stuff. So I'm going to be focusing more on face detection, and then the same knowledge can be applied to other types of APIs because it's actually very very seamless and easy to use. So and it's self-explanatory to be very honest. So excuse me. I'm going to be starting with face detection. So this is a face, and then I have, so when your app detects a face, it lets you know the landmarks on the face, lets you know the contours, lets you know the classification. So in these blue dots, that's the contour of the face. It's basically just the shape of the face, the surrounding box of the face, basically. So you can do whatever you want to do. So use case for this would be the Instagram filter or Snapchat filter or whatever you want to do with that information. So the blue dots are the contours, basically the angles of the face. And then for the landmarks, I have them in green dots: the eyes, the nose, the mouth, and then the ears. So they're in green dots. So it lets you know the positions of all these parts of the face. It gives you a point, and then you can plot whatever you want to do with that point. You can do any calculation you want to do with that information. So it's totally left to the use case of your smart application. And then we have the classification. Classification basically means the position, the states of a particular part of the face. For example, it lets you know if the eyes are closed. It lets you know if this face is smiling. So these are classifications, and then based on your use case, you can disable, you can enable. Like for example, if your use case does not need to know the landmarks of the face, you can turn that off, and then you can, if you only need the contours, you can just enable contours alone and turn the rest of them off. So it basically depends on your use case, like I said. So just to reiterate, I have the contours in blue dots around the face. You can see it highlights the cheekbones, the eyebrow, the cheekbones, yeah, the round face, and all that stuff. The nose, yeah, and then the landmarks are are the green dots where it lets you know the eyes, the ears, and then the nose, the mouth area. And then for you to understand the face orientation, because you might want to know how well positioned the face is. If the face is facing the front, or it's facing the back, or it's facing the camera, or it's turned left or right. So the Euler values. So when MLK detects a face, it lets you know the Euler values, and this is what the Euler values mean. So we have the Euler X, which is basically for detecting if a picture is facing up or down, and it's positive. It's a positive value. It's a double. I mean, it's a float. It's a positive float number if the face is facing up, and it's negative when it's facing down. And also for the Y, it lets you know if the face is facing right or left. So it's positive if the face is facing the right relative to the camera in this case, and then it's negative when the face is facing the left also. Then we have the Euler Z, and it lets you know the rotation angle or direction of that face. So it's positive when it's rotated counterclockwise, and it's negative the other way around. So let's take some samples for the face detection. This is a smiling face, obviously, and it's a single face. And then this is the result of the MLKit processing this face. So we have the bounding box with these points. It returns a rectangle, a rect, and then with all the points you can use to plot the angles. So the bounding box is what I have in white, and it also lets you know the probability that the right eye is opened. So right now, the face's right eye is actually open, and that's why we have 0.9. So the value is from 0 to 1. So the closer to 1, the higher the probability that that is case. So for this image, there's a 0.93 confidence that this person's right eye is opened. And also for the left eye, the probability is 0.98. That it means that this person's left eye is opened. And then for the smile probability, it lets you know if this person is smiling or not. So it's also a probability value from 0 to 1. The closer to 1, the higher the probability that this occurrence is happening. So for this face, I have a 0.99 confidence that this person is smiling. And then the ELA values, like I explained, the ELA values for the X lets you know if picture is facing up or down. Like I explained, if it's positive, that means picture is facing up. So looking at this face now, it looks like it's facing up, and that's why we have the positive value of the ELA X. And then for the Y, it lets you know if it's facing left or right. And then if it's facing left, that's a negative value. If it's facing right, that's a positive value. And looking at this picture here, we have the number being negative, means that this picture is facing the left relative to the camera. And then for the Z is the rotation degree, possible rotation degree, and it's also negative because it is clockwise. I don't know if that makes sense. So let's take more samples. Then I took a sample of a face with glasses and facial hair. So this is just to say that face detection also works with facial hair and also with glasses. So it detects everything. So like I explained earlier also, these are the values gotten from processing this image. The EULA X, the probability that this person is smiling is very close to zero. It's almost zero, which means that this face isn't smiling at this point. And then I have the right eye open probability. The two eyes were open, but sorry, they are already covered in dots. But the two eyes are opened now, and that's why we have a very high probability score, very, very close to 1, approximately 1, approximately 1. So it works with glasses and also facial hair. And even for a full makeup made up face, it also works. It returns the value also bounding box. The right eye probability open is almost 1, and also for the left eye probability open, I mean, it's not as high as the right eye because I mean the two eyes were not opened the same way. And then yeah, this is a wide smile, so we have almost a 100% probability for the smile, and also for the EULA X, and also for the Y, and also for the EULA Z. You can see the values interpreting the direction of the direction and orientation of this particular face in question. Then it also works seamlessly with multiple faces. So it gives you an array of faces. Then each face has all the values I had explained in the previous slides. So it also works seamlessly with multiple faces. And the beautiful thing about face detection, this particular face detection, is also that it works like if your solution requires that it works in real time, because the processing is on device and it works offline. It doesn't need interference with the internet, but it doesn't need interaction with any other tool outside your application. So it can be very, very fast. So you can process that using your live camera or whatever solution you are probably building. So yeah, it works with multiple faces. So barcode scanning, this is another API under Vision APIs. It's read codes, barcodes. It can be linear, it can be 2D, it can be QR code, whatever it is. It works. Barcode scanner works with different types of format, very, very wide range of formats. And then it even works even when the code is upside down. It's and it also helps you automatically format. Extract the formats. So it detects the format in which the barcode is. So even if it's QR code, you don't have to do any processing. It knows that this is a QR code. It knows that this is a linear barcode and all that stuff, and it automatically passes the data for you. So it can read lots of information types, from URLs to Wi-Fi information to SMS messages to email addresses to phone numbers. You can read a lot wide range of information automatically without you having to specify what exactly you want to read. So that's a win for whoever wants to implement that API. Yeah, it works even when the barcode is upside down. and automatically extracts a wide range of information, like I explained earlier. So it works with URLs, email addresses, phone numbers, Wi-Fi information, and a lot more than this. Also, we have text recognition. Text recognition basically tries to. This is actually very fun for me because I've had this wildest imagination in the past where I would want to just get a printed document and be able to copy the content from there to a digital place. Let's say, for example, from my hard copy book to a phone or a laptop or whatever it is. So this is close to what I imagined, and it works with lots of Latin-based languages, basically. So from English to Spanish to French, it works with lots of languages. So it helps you detect the text or captures the text in an image. So it can also work with live camera. Let's, for example, you want to keep tracking images on a particular text on a particular image or surrounding and all that. So it helps you break large text down into smaller units. And then these units are the blocks, the lines, and then the elements. So the blocks contain the lines contain the elements. So it lets you know the points of each of these units in the large text. So you can, so for example, I use the points to write for this image, this test image. I use the points given back to me from the processor to plot the text, to draw the text rather on the screen. So you can use it to do a lot more depending on what you would want to achieve with your own use case. And then also language recognition. Excuse me, please. For language, it also works with Latin-based languages. So basically, it identifies the language a text is written in. So let's say you are probably unsure. And even you can see, I'm very sure that we've at one point or the other experienced that with Google Translate, and where you want to translate from a language that you don't know to a probably known language. So that is language recognition in place. Like it lets you know possible languages a text is written in. And it identifies over 100 languages. And I'm very sure that very soon there'll be more support for more languages as it grows bigger. And then smart replies, it generates suggestions based on your conversation. So you probably feed the processor with your conversations and the timestamp. So it lets you know what possible replies you could give to a particular message. So it's right now it only supports English language, but I'm very sure that very soon it will be extended to more languages. And I mean, it's not for serious conversations; it's just for casual conversation between two friends, not to be used as a formal use case, basically. So it's just for a casual conversation between two or more people. So you feed the processor with your conversation and timestamp, and you can even mark it with the user ID. So you know, so the result comes back with the list of suggested replies, and you can display that to your app or whatever you want to do with that information. But it gives you a result, and you can process it any way you deem fit. So, like I explained earlier, that this is MLKit is one of the things we currently embraced at my company, Kudi. And for our use case, it's quite not so unique, but it has helped us to solve some of the prominent problems we've had in the past. And one of the problems, because it's a financial application, though, yeah, it's a financial application. And then one of the problems we faced in the past is that when people are trying to onboard, they just probably snap pictures, unusual objects, basically, like a random space, not their faces. And so we had that problem a lot in the past, and we needed a way to be sure that the picture that's been uploaded is a real face. Though we were able to try some solutions that were around before this annual kit, but most of the solutions that are currently available require internet connection, you having to connect to a server to process the data and all that stuff. But then MLKit has come because it's on device. So, and because most of our users are people living in remote areas that want to transact that on the bank and all that stuff. So we needed to like be considerate and see how well we can solve these problems. So we kept iterating, and then so far we currently use this ML kits. And so another problem we had is impersonation. Basically, even when you snap a real face, there's no guarantee that the face belongs to you. It can be a face of your neighbor or your enemy or whoever. There's no guarantee that this face belongs to you particularly. And also, we after cracking the impersonation level, we also detected that it's possible you take a picture of a picture. Let's say you have an existing photo of you, just point your camera to that photo and then it captures it. So we needed to also be sure that the photo that has been taken and stored is actually the current image of you at that point in time. So I'll go through how MLKit has helped us, machine learning in general, not just MLKit. Machine learning in general has helped us to crack some of these things. While we still have some solutions in progress, but so far we recorded a level of success in curbing some of these issues. So yeah, our goal is number one. So because of the initial problems I mentioned in the previous slide, we see that there are some fraudulent transactions that were not traceable because the picture of the person involved had no, like, we couldn't track with those images. So we wanted to reduce fraud on financial transactions. At least if people knew that their faces are on their profiles, the amount of fraudulent activities that they would want to do with their accounts would be minimal. So also we want to also achieve validating our users by their government IDs by comparing their government IDs with their current picture that they've taken. So these are the two goals we really wanted to accomplish when we were thinking about how to go about this. So how were we planning to use ML kits and machine learning in general to, use these things? So first of all is a liveness check to be sure that the person that is currently snapping and uploading this picture is a real person, and then it's the same person and it's not a photo of a photo, like a real face at that time. So we used ML kit to detect the blinking, and then that this person had blinked. I mean, your photo of a photo will not be able to blink. So it's a simple step for us to curb that fact. I mean, there are still other use cases that we could use to detect liveness check, but to keep it on the barest minimum, we just need you to blink twice, and then we also tell you to smile at that time. So it helps us know that okay, this is a real picture that's been taken at that time. And then we also use the ELA values to detect the orientations where the camera is facing and all that. So if we need it to face a particular direction, we let you know. And also, we now compare the image that you take with your government ID, because we definitely tell you to upload a valid government ID from your driver's license to international passport to some of the Nigerian IDs we use also. And then so every ID definitely has a picture. So we compare the two images, that is the one you just took after doing the liveness check, and then the image on your ID. So our machine learning team have built a server-side model also to do the comparison. So the comparison of the two images is also done on the server side and returns a score. So how close these two images are to each other. So if it's not up to a particular threshold we are allowing into our system, we bounce you back and we tell you that you should probably go and look for a better picture and better government ID that belongs to you and all that. So we do other checks apart from photos to determine scores, but photos and images is at the core of what we do to determine how close or how real this person trying to onboard is. And so this is just a visual representation of what I've been trying to say in previous slides. So we tell you to blink with both eyes. With the help of ML kits, we could detect that. And also we tell you to smile. With a job of the ML kits, we are able to know when you've smiled at, so we can use the probability values to know how well you've smiled, basically. And then, I mean, when all these checks are done, we send the image, the captured image, to the server, and the server processes that and gives us back a result. And then we tell you to proceed, or we tell you that, I mean, unfortunately, you can't onboard at that time. I mean, so far it has given us a successful. I mean, it has reduced our fraudulent transactions by a good number. and we are hoping that because we are hoping that in few weeks or few months or years, we will be very, very close to zero or no fraudulent transactions. Fingers crossed. Yeah. So now let's do some coding. So I'll be using face detection as the case study. Like I explained earlier, most of these APIs behave the same way. They return the same, they take in the same inputs and return the same, almost same outputs with unique, with little or no uniqueness. So I'm going to be using face detection as a case study, and definitely you can apply this understanding to most of the other APIs without stress. So the first point it will be to, this is where everything starts, right? Add you have to add your the library to your dependency to your Gradle file, and you can see that MLKit itself is really unbundled. That is, you don't have to add the entire MLKit to your app to use. So it depends on the particular API you want to use. So for this particular one, the dependency I'm adding is the face detection. There, we have for the text recognition, we have for the language detection, we have for everything. So basically, you won't have the problem of putting lots of code that you don't need in your application. So you can only pick the one you need. And for let me just also mention that there are two approaches into adding MLKit into your application. This is the bundled version. That it means that when you build your application and want to release it, this particular MLKit face detection library is bundled with your application. Another approach is that you let Google Play Services and do that. Excuse me, I have a bit of cough. So another approach is letting Google Play Services handle the download for you. So that means that your app will be bundled without ML But when your users install the application, Play Services handle downloading ML kits. But a con to that would be that it will require internet access and a little bit of wait time. So, but either of them works. But for this particular approach, I'm following the bundled approach where you add this dependency to your Gradle file, and then at your build time, Android handles everything, it bundles everything with your application, and again, you can ship it once, and Google Play Services won't have to do anything extra for you. So now, for face detection, there are a couple of options. Like I explained earlier, if you want to, if you need the contour of the face, you let the builder know. So basically, these are the options we have. So how to create the options we have? If you want, you can set the performance mode. Either you want it to be fast or accurate. This is similar to what we have with location. For location also, if you prefer speed, you can choose speed over accuracy. So same thing with this one. So you can set a performance mode if you want the accurate results, or you just want anything that can be done so fast. So there are two options, either the mode accurate or the mode fast. And also for the landmark, you want to know, if you are interested in knowing the landmarks, that is where the ears, the eyes, the nose, the mouth, where they are positioned on the face, you are interested in that, then you would have to turn on landmark mode. So there are two options to that also: landmark mode all or landmark mode none. That is, so by default it is none. That is, you don't want it. But if you set it on, it lets you know all the points of these landmarks on the face. And also for classification, you want to know if a face is smiling or if the eyes are opened and stuff like that. So you can also set it. It's either it is all or none also. But for classification to work, that means you have to have enabled your landmark, because classification is built on landmark. So because you are detecting the mouth, you want to know if the mouth is smiling. That means you need to have enabled the landmark for you to know where these landmarks are positioned and how they are positioned, either they are smiling or they are closed. And then you can set your contour if you need to know the points of the face, the contours of the face, that is the shape of the face, the positions of the bones, the angles and the contours of the face. You can also set it up or to all or to none. And then that's that. Then you just build. So that's you building the options you need for your face detection. It works the same way for text. You just build. So you just pass you pass the builder to your processor. But like I said, this is solely for face detection. But it works almost the same way with other MLKit APIs. So now that you've built your options like we did in the previous slide, you want to get your client. So the client for face detection is face detection.get client. So it returns the client a detector or a processor for you passing in the options you've built in the previous slide. And also one thing that it is useful here to also note that this most of the Vision APIs takes in input image. So input image can be gotten from your regular bitmap, the way you upload a picture from your gallery or from wherever. So it can process images from your bitmap. It can process image from your camera directly from your camera source. So if you are using the usual camera API, then you would use the input image dot from byte buffer, and you pass in the necessary parameters, takes in the width, the height, the rotation, and image format. And also, if you are using the new camera X, you use the input image dot from media image. So basically, what you'll be passing to the processor is an input image object. So you can process your input image like this using these methods from input image. So let me reiterate, it can be from a bitmap, it can be from your camera, depending on the camera type you're using, that camera 1 or camera X. So let's assume we have this image at this point now. So we pass that image to the detector, which is just by calling dot process, and that's all. To be very, very honest. So the process, you get the image, and then it returns a list of objects. So basically, because it returns a task, you have to listen for the success or on failure, because it happens hopefully in background. And then these are other properties that the face can get. And then you have bounds, like you want to know the bounding box of a face. Like in the previous images I used, that's the rectangle drawn on the faces, and also the Euler values. This is how to get the Euler values for all of the faces. Also the landmarks, the position of the landmarks, where you can where the left eye ear is, where the mouth bottom is, the right eye, and all that stuff. Then the contours. These are how you can retrieve the points and do whatever you want to do with those points. And also for classifications, this is how you get if the face is smiling, if the right eye is opened, if the left eye is opened. These are the probability values for classification. Also, you can track in cases where you want to actually use multiple faces. So you can add ID to a particular face in the list of faces. So it tracks that face as it moves in the frame. So it's helpful for you if you are doing a kind of live streaming and you want to continually track this particular face. So it gives you the idea of that. And then that's all so like I said, using the other APIs is just putting the dependency in. For object detection, you put in the object detection dependency, and then also the client is object detection, then you get the client to process it. And that's means similar to, I'm running out of time, and that's why I'm rushing, so bear with me please. And then that's why you have the same for image labeling. It returns list of image labels. You can do whatever you want to do with that information. And also we have for barcode scanning, it returns a list of barcodes. And then we have for language identification, it returns possible images and all that. And then we have for smart replies, it returns a list of suggestions. You can display that to the screen or as your use case allows you. And then extra notes to know is that processing must not be done on the main thread, like good Android soldiers, because it's a long processing task. Should not be done on the UI thread so that it won't freeze the UI thread. So it definitely be done on the main thread, as every other task you do for long processing. And also the resources, make sure that they are released when the activity is destroyed, because you don't want your app crashing, or you don't want to hog the resources of your users. That's being empathic. And then if you want to check more about MLKit after the session, there's an official documentation. The link is there. That is the usual developer android.google/MLKit. So you can get documentation there. And then there are lots of code samples also on Google or on GitHub of Google samples. So you can definitely check them out and start building amazing stuff with this information. And yeah, questions. And this is just to note also that cookies are hiring. In case you are interested, please do well to use this information on the screen. So yeah, I'll be taking questions now if I still have time. Thank you for listening. Thank you for joining me. MLKit, even bundled, does not work without internet access. So for this one, if you remember that there used to be a Firebase MLKit in the past, and that was what needed the internet access. This MLKit, this particular one I just presented in the session, is a shiny one and it's quite new. So all of these things I've explained so far, they work even without internet access. So yeah, this one works without internet access. So it's on device, it's offline, it's free, and it's fast because it's on the device. So it works without internet access. The next question: with ML kits, is possible to detect if two faces are from the same person? Oh no. So MLK, this only detects faces. It doesn't compare faces. And if you remember that I also mentioned when I was giving my talk is that we do the comparison on the server side because this MLK does not have the capabilities yet to compare two images. So it only detects the faces and then you can probably build. And then another problem is that it doesn't allow custom models yet. So the only two APIs that allow custom models are the image labeling and the object tracking. So for face, it doesn't allow custom models yet. So you will still need to rely on Google's face detection model. But you can do your processing on the server side. But no, it doesn't. It only detects the faces, not compare the faces. It's possible to read and written text with MLKit. Yes, it is possible to read and written text with MLKit. You just, if it's, eligible. Is it eligible or legible? I don't know. But you have to the handwriting has to be very clear enough for your camera to pick. But it's possible. I tried that. How long does it usually take to get a result with mode accurate? Well, it's quite almost insignificant because it works on the device. You would hardly ever notice. So now it depends on the device capability, how fast the device is normally, or your other your device configurations. But the model itself, because it's offline and all that stuff, it works almost as at the time of your request. It gives you back the result at the time of your request. So if you now do other processing with that information, that's where the speed might now lag because you probably want to do other heavy task with information returned from by the ML kits. But usually it's actually quite fast. You won't even notice that something was going on in the background. Maybe I missed something, but is it possible to learn persons, like know if a photo there is person A and if the same person is another photo? So, like I said, it doesn't do face comparison. It only just detects the faces and lets you know the angles, the positions of these landmarks on the face. It doesn't compare to people yet. That's not available right now with the face detection, with the ML kit rather. So it only detects faces, not compare faces. I hope that answers it. So I think there are no more questions. Thank you so much for your time. Thank you for attending this. And I hope you've learned one or two things. Do you need a device with the ML chip such as any device, any device at all will work. For example, on my own end here, I use one of the low end devices from China, and it works seamlessly. So yes, any device can. It doesn't have to be a Pixel. Can we detect the eyes direction? You can only detect the face direction if it's facing left or right or up or down, not your iris or what's that thing called. It doesn't detect the eyes itself, but the face. So yes, thank you very, very much for your time. I hope you learned one or two things to start building your smart apps. And you can reach out to me on Twitter if you have any questions, or probably during the lunch breaks tomorrow. I'll be very happy to provide one or two insights. Thank you. Bye.